Hello students, today we will start the last topic from the first chapter, that is simulation of a simple computer. So basically, what do you mean by simulation? It means to develop a working model or prototype which behaves like a real model. I think all of you are familiar with the concept of prototyping that you have studied in B.Sc software engineering, right? Where we are developing software modules. There are some examples of simulation like the flight simulation model which is used to train the pilots. The second example is video games like car racing and the model of the building that is to be constructed. Here we are going to simulate a simple computer by developing a program module which behaves like a real computer machine. It is also called as hypothetical computer or SMAC0, where SMAC0 stands for Small Computer of Version 0. The architecture of hypothetical computer SMAC0 contains the following components. The first component is called a general register. There are 4 general registers are used, which are named as A register, B register, C register and D register, which coded internally as 1, 2, 3 and 4 respectively. These registers are used to hold the data temporarily during the execution of the program. In this diagram, I have shown the number of registers and their codes. The second component of SMAC0 is condition codes. They are similar to the flags of real computer machine and mainly used to check the conditions. There are 6 condition codes are available which are reflected after the comparison of 2 values. In this diagram, I have shown 6 condition codes which are LT, LE, EQ, GT, GE and NE with corresponding condition codes as 1 to 6 respectively. Now we will see each and every condition code in detail. The first condition code is LT, that stands for less than, which is coded as 1, and this condition code set if the operand 1 is less than operand 2. The second condition code is less than or equal to, which is coded as 2, and this condition code set if operand 1 is less than or equal to operand 2. The third condition code is EQ, stands for equal to, which is coded as 3, and this condition code set if the operand 1 is equal to operand 2. The fourth condition code is GT, that is greater than, which is coded as 4, and this condition code set if the operand 1 is greater than operand 2. The fifth condition code is GE, that stands for greater than or equal to, which is coded as 5, and this condition code set if the operand 1 is greater than or equal to operand 2. And the last condition code is NE, which is coded as 6, and this condition code is always set. The third component of the SMAC0 is called as the program or the location counter. It holds the address of the instruction in the program to be executed next. CPU fetches this instruction for the execution. The next component is called as instruction register. The name itself indicates it is used to hold the instruction before the execution. And the last component of SMAC0 is memory. SMAC0 has the memory of 1000 location addressed from 000 to 999. Each location in memory hold either the instruction or the data. So these are all the 5 components of the SMAC0. SMAC0 instruction is 6-digit wide, having the following format. The first 2 digits, which indicates the operation code, which is one of the values from 00 to 10. Operand 1 is general register code, which can be 1 to 4, or the condition code that varies from 1 to 6. So for the operand 1, we can use the registers from 1 to 4 or the condition codes which are varying from 1 to 6. Then the operand 2 is always the address of memory location, and which may vary from 000 to 999. So as per shown on this slide, the instruction 01 is the operation code that we want to perform. The operand 1 over here, it is the A register, and the 501 is the memory address. So 01 over here stands for the addition of the content of A register with the content of memory address 501. So the result will be stored in register 1. Every instruction of SMAC 0 simulator has operation code. There are 11 operation codes assumed in this hypothetical machine which specifies the operations to be performed during execution as below. The first opcode is 00 and corresponding mnemonic opcode is stop, which is used for the termination of the execution. The next opcode is 01 and mnemonic opcode is add, which adds the memory location content into the register content. As given in this example, we are going to add the content of A register, that is register 1, with the content of memory address 101, and the result will be stored into the same register. Here the first 2 digits are going to show you the operation of addition. The next opcode is 2, where the mnemonic opcode is subtract, which subtract the memory location content from the register content. As given in this particular example, this 02 stands for the subtraction. The first operand is register 1, or you can say it is A register, and the second operand is the memory content of 101 address. So here the memory address content will be get subtracted from the register 1 content, and the result will be stored into the register 1. The next opcode is 3, where the mnemonic opcode is multiplication, which multiply the memory location content into the register content. As per given example, the first 2 digits are going to show you the multiplication. The first operand is going to consider the register 1, which is going to multiply with the content of the memory address 101, and the result will be stored into the register 1. The next opcode is 4, where the mnemonic opcode is move R. As the name itself indicates, it indicates move to the register. That is, the memory location content will be get moved to the register. So in this instruction, 04 stands for the move R operation, and we are going to move the content of memory address 101 into the register 1. The next opcode is 5, which stands for mnemonic opcode move M, which moves the content of register into the memory location. So the first 2 digits are 05, means we want to move the content of the register into the memory location. So as per this particular instruction, we are going to assign the register 1 content into the memory address 101. The next opcode is 6. The corresponding mnemonic opcode is compare. It compares the register content with memory location content and set the condition code depending on the result. So here the 06 stands for the comparison. I want to compare the register 1 content with the memory address of 101. It is possible that it may resulting into the first option, that is less than. So the particular condition codes that are going to set are LT and LE. So the condition code 1 and condition code 2 will set to the value of 1. It is possible that the register 1 content may be greater than the memory content of address 101. So here the condition code 4 and 5 are going to set to 1. Those are respectively GT and GE. The third possibility is that the register content is equal to the content of memory address 101, where it is going to set the condition code 2, 3 and 5 is equal to 1. And as we have already seen that condition code 6 is always set to 1. So this is what the opcode 6, that stands for the comparison, and it is going to set the condition codes depending on the result. The next opcode is 7 and corresponding mnemonic opcode is B.Sc. B.Sc stands for branch to the code, which checks the condition code and transfer the execution control to the specified location. Now in this instruction, 07 stands for the branch to the code. Here we are going to consider the CC1. If the condition code 1 is equal to 1, then it is going to transfer the control to the memory address 500. The second example stands for 07, that is branch to the code. If the condition code 3 is equal to 1, then the location control will transfer to the 900. Next opcode is 8, which is used for division, which divides the content of register by content of memory location. Here the first two digits are used for the opcode. The operand 1 is register 2 and the next operand 2 is the memory address 100. That is, it is going to divide the register 2 content by the memory address content of 100. Next opcode is 09. Corresponding mnemonic opcode is read, which get the input from keyboard and store in the memory location. It accepts the input from the keyboard and store in the memory location. The register and the condition codes is not used in this instruction because whatever the values that we are getting from keyboard, it is directly stored into the memory address. So this particular instruction will read the value from the user and it will be stored into the address 300. The last opcode is 10, which is used for print. It prints the content of memory location on the screen. Register or condition codes is not used in this instruction because we just want to display the content of the memory address 500 and 10 stands for printing the content of that particular memory location. So these are all the opcodes and their corresponding description. SMAC 0 programs are written with the help of instructions specified in the previous section. A hypothetical computer or SMAC 0 simulator accepts these SMAC 0 programs as an input and gives the result or gives the output. So as per shown in this particular diagram, the SMAC 0 programs and data will be considered by using general register, condition codes, memory, instruction register and location counter, and we will get the result over here. Now here we will see a sample SMAC 0 program for the addition of two numbers. So basically what we have to perform the sequence of instruction. First of all, we will read the value from the keyboard. So for this, the instruction is 09, means I want to read the value from keyboard and I'm going to store it into the memory address 501. here the operand 1 will always 0. After that I must have to read the second input value that I want to add. We know that for reading we are going to use the opcode 09. The first operand is 0 and whatever the values that will be given as the input, it will be stored into the memory address 502. The next instruction is that we are going to move the content of address 501 into the register, and this instruction opcode is 04. 041501 will transfer the content of memory address 501 to the register 1. Now after that I am going to add the A register with the memory address content of 102, where the instruction is A register plus the memory content of 502. Now the result is stored into the A register. After that I am going to move the content from A register to the memory location 503. So for move M we are going to use the opcode 05, and I want to move the result from A register to the address that is 503. 05 stands for move to the memory. After that I am going to display the content of address 503 by using the opcode 10, where the operand 1 is 0 because we are not going to use any register or any condition code over here. And after that we will terminate the execution of the program by using 00, which stops the execution of the program. So this is a very simple example of SMAC 0 program for the addition of two numbers. Like the same way you have to write the particular programs for subtraction and multiplication as for the homework. Just try for it. In the live session we will discuss it in detail. I think all of you got the concept of simulation of a simple computer. So thank you for the listening.